This is our lecture on accuracy and precision. So we're going to run through these examples and look at these notes. So we have this target that kind of relates accuracy and precision to throwing darts on a target. And we're going to relate this to science. How can we relate these two terms? So for the first one, I have two groups of students, A and B, who collected data on the measurement of a pencil. They use different rulers. So they want you to first draw the ruler that was used by each group. Well, if we look at this first group, this would be certain and this would be estimated. That means on this ruler for group A, they must have had the ones position marked off. 1, 2, 3, 4, 5. And I guess it was a little longer, so we'd have to go to 6. 6, okay? So they must have had that position marked off. Now, for the next ruler, this would have been certain, certain, and then estimated. So that means this ruler must have had both the ones position marked off and it must have had the tenths position marked off. I'm just going to mark off within 5 to 6 centimeters. So it has more divisions compared to the group A ruler. Okay? So the next thing is we want to use the steps for reporting each group's measurements as an average value. So we're going to do average. We're going to add up these and report the average. I think I got 6.5 centimeters. And if I added up these and get the average, I think I got 6.56 centimeters. Okay, so that was just the average. Add them up and divide by 4 because we have 4 different measurements. Okay, the next thing we want to do is find what is the deviation of each measurement. To find the deviation, we're going to use absolute value here. And we're just going to take the measurement, which was 6.5, minus the average, which was 6.5. So the deviation for this one would have been 0. They did not deviate anywhere from the average. The next one is also 0 deviation. So remember, this is absolute value. So on the next one, if I take 6.5 minus 0.3, I have 0.2 deviation. And on the next one, 6.5 minus 6.7, its absolute value is another 0.2 for deviation. So then I'm going to do the deviation for these ones. I'm going to compare this measurement to the average, subtract the difference. I got 0.03. This one deviated. This one, next one deviated 0.01. And this one also deviated 0.01. And the last one was 0.03 again. Okay, so those are my deviations. Now, I want to figure out the average deviation. So the average deviation here is the same thing. I'm going to sum up these and divide them by 4 different measurements. So it would have been 0.4 divided by 4. My average deviation is 0.1. Okay, if I add these ones up, it would have been 0.08 divided by 4. It looks like my average deviation is 0.02 centimeters. Okay, so that's what the average deviation is. So we're just looking at what is the average and how far did each measurement deviate, or is it away from the average? Okay, so we're just looking at that. So precision describes how close values are to, so like this is precision right here on that target. So it looks like all of the darts are landing in one spot. So precision has to do with how far values are, how close values are to each other. In my dartboard example, in the second one, those are close to each other. These ones are not close. That is not precise. Okay, because they're all over the board. So that's what precision has to do with. So it says, which group is more precise of groups A and B? On this one, if we look at this, we can look at the rulers. Which one has the smallest markings? It's this one. So it looks like group B is more precise. And the reason would be the ruler has smaller divisions. Okay. So the next question says, how does the measuring instrument affect the precision of the results? Well, the smaller the divisions are the increments on there, the more precise the measurements are going to be. So in other words, smaller increments or divisions results in greater precision. The next question says, accuracy describes how close the measurements are to. So when we look at accuracy, accuracy has to do with getting them on that bullseye. So that's the desired results. So accuracy, we're going to say in science, is going to relate to how close the measurements are to the accepted value, or sometimes we also call it the true value. Okay? Now, for the next part, we're going to do a calculation called percent error. This equation is one that we'd use. You don't have to remember it, but percent error also uses absolute values, so you remember we don't worry about the sign. And then you're comparing the experimental value, so in other words, what the person got for the value, to the accepted value. So they're saying if the actual length of the pencil is 6.51, that would be the accepted value. Calculate the percent of each group's results. So we're going to go back up and we're going to use the average that they calculated on here, okay? So if we look at the first one, so we're going to take the experimental value, we're going to use that average, so we're going to say for group A, it looks like they had 6.5 minus 6.51 over 6.51. And this will be absolute value. And then we would take it times 100%. If I did this, and I'm going to round this to one place since 100 only has one sig fig, I would get 0.2% error. It's not a lot of error. So if I did group B, taking their results, their average was 6.56 minus the accepted value, which is right here. They said it was 6.51 over 6.51. I need absolute value again of those, and then times 100%. I get 0.8%. So if we look at these, this number compared to this number, which group is more accurate? The one that has the least percent error, right? So which group is more accurate? Group A. Why? How do I know? They have the least percent error. They had that 0.2. That's less than 0.8. Okay, so less error means they are going to be more accurate. And then it says, how does the percent error describe a measurement's accuracy? The smaller the percent error, the more accurate the measurement. So the smaller the percent error means more accurate measurements. So that would get you through our accuracy and precision lecture that we had for today.